You know how you're sometimes faced with this big jumble of raw numbers and it just feels like pure chaos? Well, in this explainer, we're going to show you exactly how to tame that chaos. We're going to find the clear, simple story that's hiding inside all that data using some really powerful tools from descriptive statistics. All right, let's dive in. Okay, so look at this. This is our starting point, a simple set of numbers. And on its own, it doesn't really tell us much of anything, does it? It's just a list. Is this good? Is it bad? Are these numbers all clustered together or are they spread way, way apart? We honestly have no idea yet. And that right there, that's the central question we're going to answer today. You see, every single data set, no matter how messy, has a story locked inside it. Our job is to be the detectives, to use statistical clues to unlock that narrative and figure out what it's really trying to say. So, where do we even begin our investigation? Well, our first clue is all about finding the heart of the data. We need to find a typical value, a single number that can kind of represent the whole group. This is our first and maybe our most important clue. Now, the most common way to do this is with the mean, which I'm sure you know as the average. It's the one we all learned in school. The best way to think about it is like the data's center of gravity, right? If you imagined all these numbers on a seesaw, the mean is that perfect balancing point. So let's do the math. We take our list of numbers, we add them all up, and then we divide by how many numbers there are, 7 in this case. And bam, we get a mean of about 20.29. This gives us our very first snapshot of where the data center is. But wait, the mean isn't our only tool here. We've also got the median, and this one's even easier. You just line up all your numbers from smallest to largest, and you pick the one that's smack dab in the middle. So if we order our numbers, 7, 10, 15, 15, 20, 30, 45, what's in the middle? It's 15. That's our median. And this is where things get really interesting, because this highlights a crucial difference between the two. The mean, our average, can get totally yanked around by a few really high or really low numbers. We call those outliers. The median, on the other hand, is tough. It's robust. It doesn't really care about the extremes. So here's the takeaway. If your data looks a little lopsided, the median often tells a more honest story about what's typical. Okay, so we've found the center. But honestly, that's only half the story. Our next clue is to figure out the data's personality. Is it a tight, consistent group where all the numbers are pretty close? Or are the values just scattered all over the map? This is what we call measuring the spread, or the variability. The simplest, quickest way to measure spread is the range. You just take the highest value, which is 45 for us, and subtract the lowest value, 7. It's super fast, super easy. But here's the catch. It's also a bit basic. It only cares about the two extreme points, and it completely ignores everything happening in the middle. So, for a more sophisticated look, we have variance. What this does is it looks at every single data point, measures how far it is from the mean, squares that distance, and then it takes the average of all those squared distances. The only kind of weird thing is that the result is in squared units, like square dollars or squared friends. What does that even mean? It's not super intuitive, is it? And that's where the standard deviation comes in to save the day. It's simply the square root of the variance. And by taking that square root, we get back to our original units, which gives us a number that actually makes sense. You can think of it like the typical personal space bubble around the mean. A small standard deviation means everything is packed in tight. A large one means the data is really spread out. Okay, awesome. We've got the center, we've got the spread. Time for our third clue, which is all about the overall shape of our data. Is it a nice symmetrical bell curve, or does it have a long tail that's stretching out to one side or the other? This is where a number called skewness comes in. It's a single value that tells us just how lopsided our distribution is. So a positive skew, which our sample data has, means there's a tail of really high values pulling the mean off to the right. A negative skew would mean the opposite, a tail of low values pulling it left. It's basically a quick check for any bias in our data set. Now, a lot of the time, we don't just want to look at one data set. We want to know how two different things relate to each other. That's where these guys come in. Covariance is pretty basic. It just tells us the direction. You know, if one thing goes up, does the other thing tend to go up too? But correlation, oh man, correlation is the real MVP here. It doesn't just give you direction, it gives you strength on this perfect, clean scale from -1 to 1. And because it's standardized, you can compare completely different things, like the relationship between ice cream sales and temperature. It's incredibly powerful. All right, we are getting so close to cracking this case. We're on to our final clue, the big reveal. It's time to spot the data points that just don't fit in. We're going after the rebels of the dataset, the outliers.
So what is an outlier? It's basically any data point that just seems, well, out of place. It's sitting an abnormal distance away from everyone else, and you have to pay attention to them. Why? Because they can totally throw off your results, especially the mean. Or, and this is the really cool part, sometimes that weird data point is actually the most important discovery you'll make.
So how do we find these rebels without just eyeballing it? Well, a super common technique is called the IQR method. First, you find the range of the middle 50% of your data. That's the interquartile range, or IQR. Then you build these imaginary fences. You go 1.5 times that IQR distance below the start of the middle chunk and 1.5 times above the end of it. Anything that falls outside those fences, we flag it as a potential outlier. And now for the grand finale. All of this, every single clue we've gathered, comes together beautifully in one elegant, powerful picture. The box plot. This one chart tells practically our entire story. See that box in the middle? That's the middle 50% of our data, the IQR. The line inside it? That's our median. The whiskers that stick out show the range of the normal data, and see those little dots floating by themselves? Those are our rebels, our potential outliers. It's the whole story in a single glance. And there you have it, your very own data detective toolkit. You've got tools to find the center with the mean and median, to measure the spread with standard deviation, to check the shape with skewness, look for relationships with correlation, and hunt for outliers with the IQR method. With just these 5 concepts, you can turn any chaotic list of numbers into a story that actually makes sense.
And look, it's so important to remember that this isn't just about crunching numbers for the sake of it. As this quote says so well, these are essential tools. They help us understand the world, and just as importantly, they help us communicate what we found to other people in a clear and compelling way.
So the next time you're faced with a spreadsheet that looks like a total mess, don't panic, don't see chaos, see a mystery. See a story that is just waiting for you to uncover it. The only question is, now that you have the tools, what story will your data tell you? Thanks for joining me.